was working with was out, so I had to look at a substitute, and they were just ripping into this lady. It was really bad. Sixth graders.
I'm hoping.
No, honestly, they
hoping that they're
gave me
like,
out one
there
middle
is
school.
how they teach them
You know,
He was my favorite person.
The best thing to do is show power at the beginning. Just immediately walk in and start screaming.
Should I like just go and like look at the whole like question and then?
Yes.
Listen to me, Harrison, you just having great plans lately.
Wait.
Should I just get a hat like that? too?
Yeah.
Yes,
Just
you
walk
should.
in with
So
it?
this
Yeah.
is the most dominant hat
Yeah.
alive. When I walk in a room, people respect my authority.
Do they have a frog one?
Mm.
I like frogs, I don't like ducks.
They probably do. I know they have a pig one. Yeah,
I feel
although the
like
pig one was a little too sparkly.
I think they make too many jokes for it.
But no, it,
Frog sounds like pretty good.
Yeah, there's so many jokes.
luckily no one makes jokes about mine.
Right out the back.
Now I'm gonna walk in like be like,
Too many
That's-
jokes.
who wants to go first?
Those are the ones we didn't do.
I handed out, I thought I handed out last time.
Oh, I can remember.
I'm practicing my
That's-
teacher voice on here later, cause I can't.
Okay, I guess stand up. This is delightful that I've got as many, as I, just wave at the camera back there. It's right there on the ghetto tripod. Okay, okay, let's sit back down. For you in video land, just letting you know that you're supposed to have out your concentration thing. I had to hit a duo and restart the video. That you should have out. You're not gonna see the screen here. But I kind of want to just refresh a little bit about what we were doing last time. We were talking about these things that are called concentration problems. Okay, and this is section 3.2. This is section 3.2. If you're wondering which section. So if you read the textbook, which you don't, but if you read the textbook, then this would be where you can read about this. I've kind of broken it down into this. X of t, and you read, that way I'll know you're awake.
X of T.
Mass substance president times. Yeah, so this may be in grams, kilograms, pounds. It may be in liters if you're measuring some kind of like liquid. X prime of t, and we should know this now, we're in differential equations, is
Rate of change.
Rate of change. You know, so it's just going to be, the units are going to be whatever the amount of substance is divided by t, your time units. Now because it's called a concentration problem, we got this thing, we are concentrating, you know, it's a tank, whatever you're thinking about. And we're going to have a stuff flowing in, and so this is my input flow rate. This is my input flow rate. Notice this is not related really to the substance in its current form. It's just talking about the volume coming into the tank, okay? And since it's a rate, its unit's going to be volume per time. Does this make sense? You know, who put the screen on the exact other side of it? Okay. We also have what do you think the little zero means? Little O means? What do you think that means? Output flow rate. This is the same kind of thing. We're also going to have an input concentration. Now again, this could change with respect to time. So everything I have here is a little bit different than the scenario we started with when we were like putting crap into our turkey bath. These could all change with respect to time. And so in applications, you know, these aren't going to be constant over time. My input concentration, now this is different. It's a concentration. We think of it as a density. Say that word. Density. Okay. And so this is going to be like an amount per volume. The volume can change with respect to time. The volume in the tank could change. Can you imagine a scenario where that would? I mean, you just fill a bathtub and you can kind of see it. The basic thing is you're going to take your initial volume in the tank. Then you're just going to integrate your input flow rate. And remember, it's a rate, so it's units divided by time. And so when you integrate it, you're going to multiply it times time. So we just put a dummy variable integration in here. That's all that is. It's just a dummy variable integration. This is wherever you're starting the clock, and this moves on. Minus the amount outflowing out of the tank. Now you can imagine if more's flowing into the tank than leaving the tank, then what's going to happen? Sorry, what was the focus? If more's entering the tank and leaving the tank, what's gonna happen? It's gonna overflow. If more's leaving the tank than entering the tank, then
Underflow.
it's gonna underflow. Eventually, you're gonna drain the tank. Now, the output concentration is, if we assume that that tank is mixed instantaneously, everything's mixed, shook up instantaneously, then the output concentration would be the X of T stands for what again? Let's see if you were, the amount of substance at time T divided by the volume at time T. And then our basic differential equation that governs this is essentially saying that you know, the rate at which the amount of the substance is changing in the tank, that's my x prime, x is the amount, okay, is equal to the difference between the rate at which the amount of substance is entering the tank minus the rate that's coming out of the tank. Does this all make sense?
Yep.
Okay, so now, what I want to do is I want to like put us into a challenge to actually try to use this in a problem. And so I just figured, okay, let's just go to the textbook and try one. So here we are. Are you going to listen? Are you going to listen?
Yep.
I mean, I can throw it up. I can try to throw it up on the screen here, but. A nitric acid solution flows at a constant rate of 6 liters per minute. Try to grab the important things as I read this. Into a large tank initially held at 200 liters of a 0.5% nitric acid solution. Now the moment you hear 0.5%,
Or
200 liters, yeah, I'll read it again here. I'm gonna read that sentence again. A nitric acid solution flows at a constant rate of 6 liters per minute into a large tank that is initially held at 200 liters of a 0.5% nitric acid solution. The solution inside the tank is kept well stirred. That means like instantly everything's uniform throughout. That's essentially what it's saying. And flows out of the tank at a rate of 8 liters per minute. If the solution entering the tank is a 20% nitric acid solution, determine the volume of the nitric acid in the tank after T minutes. That's question 1. Question 2, when will the percentage of nitric acid in the tank reach 10%? So let me just read both those questions again. Okay, if the solution entering the tank is a 20% nitric acid solution, determine the volume of the nitric acid solution in the tank after T minutes, and when will the percentage of the nitric acid solution in the tank be at 10%? Okay, so that's what I want you guys doing. Okay, think about that. Think you got this sheet. You guys set out on that and just think about what to do with this problem. Sorry, Grace, what?
What was the 20% for?
The 20% was for the I'll read it just as they say it here. If the solution entering the tank is a 20% nitric acid solution, determine when the volume of the tank is, what the volume of the tank is after T minutes. And you guys at home better be working on these.
What question in the textbook?
This, I don't know, I think it's like question 3. That's a good point.
type in the number of the page?
Yeah. It should get me close. I think it's 118. 118? Yeah.
Do you guys get?
Right now it seems a little close. I don't know if I. Oh, what do you mean?
No, I'm asking.
It is 1.2 liters per minute.
Is that just our water? Yeah, that's what I was saying, but Oh, right. But the percentage wise.
The concentration is right. That.
Oh, XT over VT.
Do you guys get a DMT?
Ay, ay.
Not yet.
Cause I feel like I did, I think I can choose one.
Right. I put it all over.
Okay.
But so, does it, no, it's not matter.
Genographics are doing,
This one's 200.
I definitely-
This one's 20.
Because the expertise is years.
So I think it should be okay.
Cause like liters in the minutes is derivative and
So
it's
since solution and comp is 20%, right?
yeah.
It's 20%. Yeah.
So wait, are we trying to find the volume of nitric acid or the whole volume?
Volume of nitric
Volume of the
acid.
tank.
Cause I just kinda thought it was just like, it's just like, you got 6 going in, 8 going out, and so you just do that and you get 20 minutes, 20.
You got 8 going out, yeah, so it's the volume
That
VT is
seems
200
too
minutes
simple,
15.
you know what I mean?
No, and.
I think.
Like, I feel like you're right about the 20%, like, I'll just like, that just makes too much sense.
Yeah. I'm
Okay, this, can you guys read it here, sorry.
And then fiddle with things.
There's the actual problem.
What I'm getting, yeah, like the differential equation I got
Oh, but then we have to
was,
take into account that.
x prime sub t equals 6 times the
Well,
0.2
So
minus
that's-
8 times 1 over root of t.
Actually, okay, does this look, cause I feel like
But
it's too simple, like what I did, I'm just talking about the
Like-
volume, cause you just got like.
So Sean, is it, but
one
the
goes out.
Because the volume should be 200 minus 2T.
Right?
Oh, yeah.
Yeah.
So because, you know, you have more,
Yeah,
DS, he said it's
you've
just like
got
arbitrary.
less
So
flowing in.
that makes, but I feel like it's
than
too.
flowing out, so you're
That's what I was
you're not
thinking, but-
Yeah,
grabbing.
but like,
I don't
just put
know.
SDT.
Yeah.
No, if you're thinking that, I
Well, that's what I
believe-
thought
So-
originally,
so
but then when Grace brought up the
start
Arlington talking about the
filling in
20%,
some
then
of
I was like.
I think that's the
I
second
think the
question.
volume.
Let's see if that
Oh,
is.
yeah.
What's the second question?
The
One
second-
more percent of nitric acid become 10%.
I think the first one's just about like this crap, it doesn't matter about nitric acid.
Oh.
But then the second one, that's when things get complicated and you gotta like.
Okay,
okay, Yeah.
okay.
It's good.
Okay, okay.
Oh, okay, so Professor, I'm a little confused about some of these variables.
That's fine.
And I know that you have nice little descriptions explaining what each variable means,
Right?
but I'm still a little
What you
confused.
work with Tommy here.
Oh,
Yeah.
container.
Because the
Yeah.
flow rate in,
Yeah.
the flow rate out, and the concentration are all staying constant, I think.
So volume, I got 200 minus 2t.
So I think those are all just.
Okay.
I
So then,
I can
Five
use the
to
four
variables,
here to
eight,
be
and
U
the rate
four.
at which
Yes,
amount
yes.
of substance is changing
Okay.
in the tank?
And then that
Would that be the nitric acid?
Two, I think.
I told him
That makes sense.
That'd be the change in nitric acid.
So then integrate and then find whatever,
I was thinking
It's like
you
you fill out the whole
10
differential
to
equation and then it's a little weird, but it works.
solve for x.
Just 0.2.
If I set it up right, it gives.
So then, two hundred liters would be
It's 10%.
50%
Okay.
of the tank.
So I just gotta figure out what the hell
Asking when that percentage
VC
is
lies.
Just because of our concentration.
FI
Yeah.
flow rate into
No.
is 6.
So,
CI concentration
so what if it goes
is
from
22.
Okay, let's pause, okay,
How do you want to?
so if we're here, A nitric acid solution flows at a constant rate of 6 liters per minute. What do you think that represents? I mean, of the things that are on that, what do you think that represents?
Check on
The
right into the container.
the rate into the container. So on our sheet, that would be FI. So if we're looking at that, we would have that FI is equal to just 6. It's flowing in a constant rate. Okay, so into a large tank that's initially held at 200 liters. Now again, look at the sheet that's there. Out of all the quantities that's there, what do you think that represents? The 200 liters, what do you think that represents? V of 0, isn't that the volume at time 0? So that would be my V0 is equal to 200 liters, and this is 6 liters per minute. Okay, now they're telling me that the tank is initially has a 0.5% concentration. Okay, now you guys help me out. If you're thinking of x of t, what's t going to be? What's t going to be? What's t in this problem? What would be t? Time, and specifically what units of time, just looking at the problem. Minutes, and I would agree that if I'm thinking about this, my t, now that, do you guys remember the definition? I hope so. Do you remember the definition of a function? Okay, is that related to the domain or the range?
Both.
No,
Well,
the t.
The t is the domain. Yeah.
Okay, now x of t, what does x of t represent here? The range, good. Now in the problem, what do you think it represents?
Concentration at a time.
It's not necessarily concentration, it's the amount.
Oh.
How are we gonna measure our amount of acid?
Liters.
Probably in liters. Does that make sense? So we're thinking of x of t as being the amount of acid in liters at time t. Okay, the next sentence is almost not important. The solution inside is kept well stirred, blah, blah, blah. This is where it starts becoming important. Flows out of the tank at a rate of 8 liters a minute. Okay, now what do you think that represents in here? That's our FO. And again, it's a constant in this problem. In other problems, it won't be a constant necessarily. Okay, if the solution entering the tank is a 20% nitric acid solution, So I have this stuff coming in, and it's 20% acid. It's 20% acid. Okay, so now let's just take, well, I guess I'll come back to that. Then it's just asking us to determine the volume after some time t. We can do that without any of the other parameters here. And when will the percentage of the nitric acid in the tank reach 10%? Instead of looking at that, the harder one, let's do the easier one first. Let's talk about the volume. Look at the equation for the volume. Our equation for our volume, I'm just thinking about the volume. The volume at any time t is equal to
200. Well, 200.
V naught, and then plus, and I want you guys to start thinking about doing these.
Integral.
Integral
From 0 to t.
0 to t of,
F initial, that's the
Okay,
end,
fine.
minus the integral from 0 to t of but that's, yes.
Okay, so if you haven't done that, do that. Answer that question. If you haven't done that, answer that question.
So what would your initial condition be?
X is 0 lit. The problem is my C value is negative 3.9 times 10 to the negative 7, because it's multiplied by, because I get this thing. Here, I'm going over 74, and use that, which makes some weird things out.
Yes.
I'm not sure if I did it correctly, but yes.
I like a lot of what I see, for sure.
Okay. I'll,
Work on that one, number 7.
oh, you're only working on new one now?
Yeah, we can start on the new one.
Okay. I didn't solve all that.
That's a homework problem, so you're doing your homework, I'm not giving you extra work.
I guess it'll be the first time I actually do my homework.
Thank you, Ethan. Okay, what'd you guys get? What'd you guys get for the volume at any time t? Does that make sense that you get 200 minus 2t? Okay, so I mean, since this is just a constant, this is 6, this is 8, these integrals, we hope even, sorry, okay, I'm not gonna go there. Okay, we hope that anybody can really do these integrals, and so when we're done, this was our initial thing, and we get v equals 200 minus 2t. So we know at least that, and if you look in our differential equation, if you look at our differential equation, that's important in that second part. You can see the x over v in there in our differential equation. So we already know that our differential equation is going to be more complicated. I mean, if you're just looking at it, it's going to be linear. You know it's going to be linear, but it's going to be more complicated because of the 200 minus 2t's down below. Okay, so now let's go to a little bit the thing that makes it a little bit more complicated, which is talking about the volume. I mean, what we have. We know that, and this is when I just wish I could pop back over to. Can you guys see that or not? I mean, I guess you can see it on your own sheet. Okay, if I'm looking at CI is the input concentration, but that's in an amount per volume. So if you're thinking about this, you've got this stuff flowing in at a rate of, flowing in at a rate of
6 minutes.
6
Liters.
liters per minute. Well, let's just look at that 6 liters. Let's just think about that 6 liters. If I'm just looking at the 6 liters, what percentage of that 6 liters is acid? So if I just grab 6 liters of this stuff, 20% of it is acid. Now this is a worthless calculation, I'm telling you right now. But how much would that be? How many? So if you got 6 liters and 20% of it is acid, how much acid you got?
1/5.
What do you have? You would have. How do you do this? Explain this to your little sister. They're like, Harrison, come help me. And he's like, I got this problem. They got 6 liters, and they say I got 20%, and they want to know how much I got. How do you do that?
Multiply.
Multiply, okay? You'd multiply what?
Numbers.
Numbers, thank you. Sean?
6 times 0.2.
6 times 0.2. Okay. Okay, now you guys tell me what we get. 1.2. Now that would be 1.2 what? I mean, as far as this problem. Liters of what? Acid. Are you with me? Are you with me? But we're talking about the input concentration, but that's the amount of acid divided by the amount of acid divided by the volume of that. Well, what's the volume of the acid? 6 liters, so it's going to be 1.2 divided by 6, and you end up with 0.2. So when they give you the percentage, they're really giving you the input concentration. That 0.2, they're really giving you a gift at that point in time. Okay, so for that part of the problem, you know that answer, you know that that's your 0.2. So now we now have CI. Okay, the only thing left is to determine, well, we have FI. Do we have everything that we need? Do we have our volume? So now let's talk about the differential equation. The differential equation would be what? You help me. The differential equation would be what? X prime equals 6 times 0.2. That's my input concentration. Minus 8. That's my input flow rate, and then
1 over 200 liters minus 2T.
okay, 1 over 200 minus 2T, and then times x of t. Or I mean, it's probably easier to see it as being that, like that. But as far as solving the differential equation, it's probably best to put it like this. Now classify this for me. Partial differential equation, we all know, the answer is going to always be no. Okay, what's the order? And it's, do we have a technique for solving that? So go ahead and start solving that. And Connor, you at home, Connor, you better be working on these. Connor. If you ain't got your phone as a calculator at some point, that's fine.
Do you have any paper, like scratch paper? No, I don't want to.
Doesn't matter, Harrison.
Thank you.
Some JMU.
Yeah.
You pay enough.
Yes, but you have to pay money to put money on your flex. You have to pay money to
Don't even
money.
get me started. I was here as a student.
Oh, I didn't know you went here.
Yeah.
I'm sorry.
No. This place saved me. That's why I came back.
No, it's good.
And as you're doing this, remember, this is problem number what? 3. So yeah, okay, and usually they start easier and get harder. So I didn't assign a lot of problems, but I did assign some. watching this video has gotta be painful. You're just watching your classmates do work. You can scroll, you can scroll.
I think, yes, that is what I thought. Cause I've simplified, this is 4/100 minus t, but I did get.
Okay, guys, for sake of time, just stop and compare what you're doing with other around you. Just see if you're on the right track. See if you're on the right track there.
I do this interval.
And then just jump over and.
I just, cause I think you kind of.
Oh, I didn't see that, yeah.
I was trying to think of the linear.
You guys comparing stuff here.
What did you do? I added, so.
Oh,
I added
you
this
have
over
it, I'm right
here,
here.
and then
So,
I
yeah, we're
used that
like-
as my P. And then I tried to get my.
This is 100.
Yeah.
That's so unfortunate.
Brianna,
Yeah.
how do you do that interval? I don't know how to do, cause it's like one over a square root.
Why do you have a
I did that, that's why I got my root. I kinda completely screwed it up.
Where did you get negative 1 half from?
Although actually, hold on.
Isn't that the interval or this?
I yeah, I did a use of for this right here, so I can do that in one to
You forgot in your PLS, it was an 8 over that whole legend, that's why.
Put that outside, so I make it.
Right, I don't know where your 8 went, you had the 8 and then it went away.
I just made it disappear.
It's okay, I did that too. Because it's, you have like the 8.
Oh, so it's gonna be like, wait, it's gonna be 8t over 200 minus 2t?
I think so.
Yeah.
I'm just double checking to make sure I did my control correctly,
Wait,
because
what?
I'm suddenly feeling.
Can I see your work?
Yeah.
I'm not
It
ready
might
for
not
one.
be right.
What have I?
So like,
Okay.
How you doing?
I've watched
as
this.
a use, so.
Okay.
I think you need a -1 there. Like, cause if you
Thank
have
you.
the u being 100 minus c, then.
My thought process here.
Oh, yeah, you just read it. Yeah.
Okay,
Divide.
so, first of all, we've got 2 tanks. I think
What
it's
did you do
broken.
review?
1 tank going to the other.
Mhm.
So the first initial line,
Wait, isn't mu?
so you just, variables,
For
one,
you?
you get this,
T to the negative 4.
Oh, that makes sense, never mind.
Because
This should be 60. Well, I caught something already. Me and my messy writing moved that out, okay.
Thank you, Brady.
And then, yeah, this is going to be geometry, right, this whole thing.
Yeah, I have a 1.2 in the, integral. When you integrated, did you get 1.2 times negative 1/3?
Did I get this right with 16?
Minus t to the negative.
I think this is right.
Yeah.
For the first tank.
Okay, Brianna, is this the -4 power?
Yeah.
Okay, I can do math.
It's okay, I messed it up over.
Okay, but now that begs the question,
Thought
how the hell do I do
that
that?
would
I no, I know how to do that, I can do that.
Negative,
Yeah, negative 1.
I'm having x of t be a negative equation.
Whatever 20t.
But
Out.
I
When
think
you,
the-
okay, I got,
No, I haven't multiplied by
I
one.
got 1 over 200 minus 2t to the 4th power.
That's just, cause that's not actually, hold on.
Yeah,
So you get a 3.
It's the same.
Yeah, so I forgot about that.
Yeah.
So I forgot, my payback is actually 8 divided by 1 over 2t.
Q is just one point two.
Integration.
Yes.
the derivative of this.
I had to like write it, I had to write it on the side. I was like, natural log is this?
Natural log of this. So yeah, I think about it, it's like, when you take the natural log, you're gonna get one over some shit. Yeah, so I would like take the derivative and like see how I can cancel it out, so it's negative 4. Because when you multiply the 8, this would be to negative 1/2. Yeah.
Figures and pencil.
No, I'm doing my new fun stuff.
It's not like the equation is pretty hard, it's just
I'm getting close.
so much stuff that you could fail on. Ay.
Okay, I'm gonna grab the reins, just to make sure we're all heading on the same page. How many people recognize, like, identify P and Q and put it in this form? Hopefully we've beaten that in enough. Okay, this integral, I'm really hoping you can almost do without making the U substitution. But some of you might still have to make the U substitution. But when you did this integral, ignoring the 4, what would you get?
Natural log of 400 minus 2.
So, because the t's on this side and not that side, it's going to be a negative, and that's gonna make a difference in our model. So this is a constant, so we have -4 natural log of 100 minus t. Now, you want mu, so what should you do with that 4? You gotta put it up because you know that you're gonna want to use the fact that E and natural log are inverses of each other.
So I would put in my numbers.
Are you with me? Okay, and so then if we're getting mu, it's gonna be e to the integral of p, in this case dt, which is e to the natural log which is just
1 over all of that.
yeah, we could just do 1. Let's go with that one. Okay, now if we're thinking about what our solution x would be, remember the formula. It's going to be 1 over mu, but that's going to be, flipping that up, times the integral of, okay, and we would have our mu, which is again and our q was 1.2, so that we could even just throw out there if we wanted. dt, and then we have plus c. We could have plus c. Now I'm confident you guys can do this integral. Okay, are you pretty confident that you can do this integral? Okay, and then we've got this c right here. That's still we have to find. Now let's think about our initial condition. What would x0 represent? Well, because that's going to determine our c. Think about the problem. What would x0 represent?
Initial population, or initial amount.
So what does x represent again? The amount of substance, so the number of liters in our initial tank that was nitric acid. But what was the concentration in our tank?
0.5 times 200.
0.5 times 200, which is, thank you, author.
1 liter, it's 0.005.
1 liter, yeah. So that makes it easier. Now, once you've done this integral and simplified, would you be able to use that to determine C? Would you be able to determine that, you find that to determine C? Okay, then you have your model for any moment in time. The moment you're done with this integral and doing that, you've got your solution, x of t. Now, once more time, what does x of t represent? The amount of substance at any time t. Now, what was the question that they asked? When will the demonstration.
No, it's
Oh,
one
sorry,
percentage.
okay, here we go. When will the percentage of nitric acid reach 10%? Now, once we have our X of T, how do you find the percentage of, this is the amount of nitric acid, how do we find the percentage of nitric acid?
Divided by me.
Divided by your volume, and what was our equation for our volume? 200 minus 2t, which I'm gonna just do 100 minus t, because that's gonna make it easier for you later, when you look at the problem. This is going to have the same form. You notice you're gonna have some 100 minus t raised to the, you got a -4, you add 1, you're gonna get a negative, you guys have done it. -3, okay, so you can be thinking about that. You find this, and then the question is when will this be what percent? When will this be what percent? 10%, so what decimal is that? 0.1. Okay, and then when you, I'll just put the 0 there so we see the 10. Okay, and then all you're going to do is take out your calculator, do some algebra, and find that value of time.
I'm just confused why it's 200 times 1 minus t.
You wrote the BFT wrong. It's 200 minus 2t, not 200.
Oh,
minus
thank
1.
you, Grace, thank you. I wanted it to be that. Yeah, no, you're right, it's 200. This is why I never get A's on my own tests. I mean, it's not true, I do get A's, but I never get 100s on my own test.
I feel like I've gotten something wrong because my X of t is a massively huge equation.
Okay.
Well, it's
For which one, Ethan?
the first one.
Okay.
For 3. It's not massively huge, it's just you can't solve without it, like, maximum.
My thing, when I did it, my C was equal to some number times 100 to the power 4, which seems
Yeah, it's
unduly large.
negative 3.9 times 10 to the negative 7, I think.
I got 5 or 4.
Or 10 to the 8.
Wait, what did you get?
Negative 39 times 100 to the power 4.
Yeah, times 10
I
to
got
the
48
8, yeah.
One minus.
No, it's because C, you get negative 39 equals C.
So you see how these problems can take a while, you see how these problems can take a while.
And they will not be on the test because it takes so
No,
long.
they will be on the test, but written in clever ways.
I think I got.
How did you speak positive?
The negative.
I can't
from
believe
the
we're filming
negative
this lecture.
three-
This is, I can't believe this is the lecture we're filming. This is-
No, I know, they're
This is
gonna
like,
watch
you
it. so
divide by
this is-
negative
They're gonna be like, you know,
I literally,
especially-
so we just did a problem, we did
Yeah,
homework.
When you take the derivative.
You tricked me,
the
Professor,
power
don't
of the
worry.
power
That's
of one,
what
so
today's
when
class
you
was.
integrate, you divide by the new power.
Although,
Bamboozled.
I definitely.
Can I see your interview?
Yes.
Okay, for sake of time, since the hour is coming to an end, I will let you do your math, later. I trust you with the math. I especially trust you with symbol lab and the math.
Yeah, you didn't simplify.
This is one of the problems I assigned, be ready to be afraid.
Oh, man.
That's.
Beginning at time t equals 0, the fresh water is pumped in at a rate of 3 gallons per minute into a
I see.
60 gallon tank initially filled with brine. Okay, so the resulting less and less salty mixture flows at a rate into a second 60 gallon, a what? Second 60 gallon tank that initially only contains pure water. And from there eventually spills onto the ground. Assuming perfect mixing in both tanks, when will the water in the second tank taste the less saltiest? And exactly how salty will it be then compared with the original brine solution?
That's horrible.
Oh, so you want the ratio of how salty it is?
I'll let you guys fight with that. So guys, listen to me. take your homework with you over break. Not because I believe at all you'll do it, but because like when you're bored over break, you can say, oh, I've got my homework, and then you won't be bored anymore, I promise you. You know, the comparison is between doing homework and what was boring you, that will no longer be boring. Okay, look at me, 85 on 81 is what? No, sorry, 85 on 81 is,
Speed limit?
no, reckless off, reckless off. 85 on 81 is reckless off.
Speed limit.
I need you back, I need you back. We're done.
Have fun sleeping.
You got to get them back to book.
Okay, I guess I'm gonna pull that out.
You as well, Brianna, have a good spring break.
I know.